Hi, everyone. Welcome back to Let's Make a Better World. I'm your host, David Tear, and I think this is my fifth video on my series on space travel. Today, I'm going to talk about space colonies, and this is a picture of a couple of O'Neill cylinders in the middle of this slide. Anyway, I'll get to that later. Let's begin. So, the main pioneer of building space colonies, I think, was this guy, Gerard O'Neill. I don't know how many of you guys are familiar with him, but he was a astrophysicist. He had a PhD in high energy physics. He was born in 1927. He died, I believe, in 1992. But he graduated from Cornell. He got a PhD in high energy physics in 1954, and then he became a professor at Princeton University. And while he was a professor, he came up with this idea. It was actually a serious plan he came up with, and he worked out all the details. He came up with a serious plan for building colonies in space, basically cities, large and habitations in space. You can call them space colonies, space islands, whatever you want to call them. But there's a picture of him on the upper right. That's his first design he came up with. It's the design of that one is what's known as a Bernal sphere. The one on the bottom is an example of an O'Neill cylinder, the interior of an O'Neill cylinder. I'll get into these in more detail later, but anyway, he had different types of designs, but the main ones he's known for are the O'Neill cylinders. And I'll go into the specifications of the designs later. But the picture on the bottom right is just a picture of what the living area would look like inside one of these things. Be kind of strange because I guess you could see other people upside down if you looked way up. But I'll get into that more later. Anyway, I want to talk about the details of these space colonies that O'Neill had in mind. Where would we build them? Where would we put them? And it turns out that what O'Neill had in mind, and I think a number of other astrophysicists space visionaries have imagined putting up at these points called Lagrange points. In case you guys don't know, they're for any two massive bodies like the Earth and the Moon. I guess those are the ones we care about here. There are 5 points known as Lagrange points. These are the 5 points where the gravity of the Earth and the Moon would cancel. I think Lagrange, he was a famous 18th century mathematician and scientist. He actually worked out the details of this, and it's true for any two massive bodies, but in particular for the Earth and the Moon. And there's only two of these 5 points that are stable. The ones marked L4 and L5, and they would be at the third. Each one would be at a third vertex of equilateral triangle, with the other two vertices being the locations of the Earth and the Moon. So these things would be pretty far away. They would be as far away as the Moon, and as far from the Moon as from the Earth. So they'd be pretty far away. They'd be like a quarter of a million miles from home. But if you're living on one of these things, you'd probably be used to that. So I guess you'd get accustomed to not living so close to home. And you'd probably be able to take trips home anyway. But anyway, or to the moon if you wanted. So that's where they would be located, and these areas around L4 and L5 are actually pretty big. I mean, they'd be big enough to house thousands of these colonies. They wouldn't be actually at the points; they would be kind of orbiting around the points in these stable, kind of kidney-shaped orbits. But they would be stable, so they wouldn't go anywhere. So those would be the suitable locations, and the first thing you'd have to do, I mean, O'Neill came up with a whole program for building these things. And, he came up with this design model, I think in 1969. He worked it out in more detail during the 70s. He even wrote a book, I think in 1974 called the High Frontier, where he made a big case of building these things. He really wanted them built. And he argued that it could have been done. All of this could have been done with the current technology at the time. This was like 1970s technology. He argued that we could build these things with all the technology we had. Well, almost all of it. There was one invention we would have needed called a mass driver. We actually already have those. I guess it took a little longer than he expected to build them. I think the first mass drivers were built maybe about 10, 20 years ago. I don't know. But anyway, I'll get into that in a minute. So, in order to build these colonies, we'd first have to have some lunar colonies, lunar mining colonies. And, um, I guess it's unfortunate nobody's been back to the moon since 1972. But I think during the 70s, most people imagine we would keep going back to the moon. Not only that, we'd have permanent operations on the moon. They depicted that in the movie 2001: A Space Odyssey. Most people thought that was going to happen by then. It didn't. Unfortunately, I think even Gerard O'Neill imagined we were going to have that. We would have needed it to build these space colonies. The first thing we would have needed to do was build a mining operation on the moon. And, we'd have to mine all the materials. And why would we have to do it on the moon? Well, the simple reason is we'd have to launch them from the moon. And otherwise, if we built them on the Earth, we'd have to launch them off the Earth. And since the Earth is so much bigger than the moon, the amount of energy required to launch them from the Earth would be much, much larger than the amount of energy required to launch from the moon. So it'd be much easier to, first have this lunar mining operation on the moon, and then build all the materials for the space colonies there, and then launch the materials from the moon. And how would we launch them? Well, this is where O'Neill came up with another idea known as a mass driver. He actually built a prototype. The picture on the bottom right is him along with two of his associates demonstrating a prototype of a mass driver. I think they had a small mass driver that worked at, I think it launched things up to maybe 10 or 20 miles an hour. It wouldn't have been big enough for this mining operation, but all you have to do is scale it up. So they basically have the technology. It wasn't really complicated technology. It's basically the same technology I think used for the maglev trains, maybe even simpler than that. I mean, it's just you would ride on a magnetic wave basically. The thing would be in a I guess a metal container, probably an iron container, a magnetic material, and this mass driver would work kind of like a particle accelerator, except instead of accelerating a charged particles, would accelerate this metallic bucket. The science is very well known for how to do that. And he even demonstrated a prototype model. So once we had these things, if you look at the picture on the top right, this is a picture of the lunar mining operation, and you'll notice there's a strip. I don't know if you can see that, but there's a long strip going away from the factory, I guess, in the front. And that would be where the mass driver is located. So it would be a long strip, strip where the bucket would accelerate. And I guess by the time it got to the end of the strip, it would reach escape velocity, which I don't know what the escape velocity is from the moon, but it's a lot smaller than the escape velocity from the Earth since the moon's gravity is so much smaller. So once it got up to escape velocity, it would be launched off the surface of the moon, and then there'd be a spaceship that would pick up the payload, it would pick up the bucket and take it to the colony. That's how it would work. So, pretty simple idea. I guess it would have required a lot of manpower, but even it wouldn't even really require that much manpower because most of this operation could be automated. I mean, even the 70s, we had industrial robots, and yeah, I guess he even talked about um, you know replicating robots. That von Neumann had envisioned in the 50s. I think he even imagined having robots build other robots so that this colony could grow exponentially. But anyway, um, so yeah, that would be the first thing we do. And then once we had all the materials, sent up to where the colonies are going to go, we'd build them, we'd assemble them there. And the first colony that O'Neill envisioned, he called it Island One. I guess it could go. He also called these things space islands. Uh, the island one would have the form of what's known as a Bernal sphere. Actually, the first two islands, you imagine, island one and island two, they'd both they wouldn't be cylindrical like later designs. They'd be spherical, and they'd be much smaller than the O'Neill cylinder. So the first one would be pretty small. I mean, it would be, I guess, I don't know. I mean, it would still be the largest thing ever built in space, but it would have a diameter of 500 meters, half a kilometer. And it would um, um, it would rotate on its axis. That would produce artificial gravity. All these things would rotate on their central axis, the symmetry axis, so that colonists inside would feel ordinary weight if they were on the outer portion of it. They feel 1g at the maximum of 1g inside. Their weight could be varied if it was a spherical or cylindrical design. I'll get into that more later. But anyway, that's what these things would look like. That's what the first two would look like, the one on the top right. But colony one would be, 500 meters in diameter. Like I said, would have to rotate 1.9 times per minute. 1.9 RPM. So I guess once every 30 seconds or so. I don't know if that would make the colonies dizzy or not. He didn't really talk about that. The other thing he didn't talk about was the Coriolis force. It turns out there's another fictitious force, not just a centrifugal force of a rotating object. There's also something known as the Coriolis force. So if you move something in a given direction, you would feel a force perpendicular to that direction of motion. That's same force that produces the trade winds on Earth and hurricanes and tornadoes and all that nice stuff. That is something I think we'd have to worry about with these colonies, and I don't remember ever reading anything by O'Neill where he addressed the issue of the Coriolis force. I don't know how serious a deal it would be. I guess one consequence would be if you're playing catch outside with your friends, the ball would just curve by itself. You wouldn't even have to give it a curve. But anyway, enough of that. So then colony two would be just a larger, island two would be just a larger version of island one. It would have a diameter of 1,600 meters, 1.6 kilometers, or about 1 mile. And this one would house 100,000 inhabitants. And O'Neill was very, very optimistic about when these things could be built. I mean, I guess he considered, like just the feasibility of engineering and design and, manpower that would go into it and all that. And he estimated that Colony 1 could be built as early as 1988 and Colony 2 as early as 1994. I remember reading this in the late 70s. I got all excited about this. I wanted to be one of the first colonists living on one of these things. Unfortunately, it hasn't happened. It's 2024 now, and we still don't have any space colonies. The best we have right now is the International Space Station, which I'll probably never get on. I still want to go into space someday, at least orbit the Earth. That's all I ask before I die. I don't think I'm ever going to live on a O'Neill cylinder because I kind of doubt that they'll be built while I'm still alive, fortunately. But, you know, maybe in my next life. I don't know. But anyway, so then Colony 3 would be O'Neill cylinder. And there's a picture of one on the bottom, right? And these things would be very long, and you'd have to have two of them. You'd have to have at least two because they'd be rotating, and in order to provide stability, otherwise it would act like a gyroscope. It would just spiral all over the place. You wouldn't want that. So in order to make it stable, you have to have two O'Neill cylinders rotating in opposite directions. Then the whole system would be stable. It wouldn't be a gyroscope. Um, and these O'Neill cylinders would be really really big. I mean, just the diameter would be he estimated the diameter of island 3 would be 5 kilometers, and the length would be 30 kilometers. These things would be huge. And I don't even know how many inhabitants they'd have. I think at least 1 million. So these things would be huge. I mean, they'd be like large cities, basically. Large cities in space. And I want to talk about the interiors of these O'Neill cylinders. So there's two portions. I mean, the cylinder has the cylindrical portion, and that would be where the farming areas would be. So people wouldn't live in the cylindrical portion, but there's a picture of it on the top right. I think you can see the Earth through the window. These farming areas, the whole cylinder part would have like 6 strips alternating between farmland and transparent windows, transparent panes. And the idea would be, and then you'd have these big mirrors on the outside. I think you can see the mirrors in the picture on the bottom right. Those big long things outside the cylinders are mirrors. Those are big giant mirrors that reflect sunlight into the colonies, and the mirrors would be just outside the transparent portions, and they would shine sunlight onto the farming area opposite of it. So that's how the farms would get their sunlight. And that's how you could grow food in space. So Neil even imagined we might even be able to end world hunger by doing this. And we might, I don't know. But so that would be the farming area, and the part on the bottom, the picture on the bottom shows the living area. This would be on the hemispherical end caps. So the end caps are just the portions that are on the ends of the cylindrical portions, and that's where the people would live on the interior of these things. And I thought these living areas were really, really cool when I first learned about them. I mean, you could vary the amount of weight you feel while you're living on them. I mean, if you were standing on the outer part, the part that's the farthest from the rotation axis, you would feel normal weight, 1g. Because of the rate at which the colony is rotating about its axis. Uh, so the people on the outside would feel ordinary weight, but then if you wanted to feel less weight, all you'd have to do is walk up towards the central axis, and your weight would vary linearly according to how close you are to the axis. So, and you could even imagine, O'Neill imagined that we could have a zero gravity recreation area in the middle of this thing. That's what this portion is on the top middle of this bottom picture, the part near the central axis. That would be a zero gravity recreation area. You could do all sorts of fun sports and recreation there. You could fly. You could, do some amazing hand gliding, amazing acrobatics. I mean, you name it. So, pretty cool design. Another advantage of being able to vary your weight on these things, if you wanted to work with heavy equipment, so you were doing construction work, you could just go to a part of the colony where the gravity's less, the artificial gravity's less. Yeah, it wouldn't be so stressful. Anyway, uh, and the last thing I want to talk about is alternate designs, and so this would be an ongoing project, obviously. I mean, I just kind of talked about the beginning of building these colonies. Once we had a few of them already, we could do different kinds of designs. And as a matter of fact, there've been a number of other, I guess, astrophysicists or people interested in building space colonies come up with other types of designs other than the Bernal sphere or the O'Neill cylinder. I like those two the best, but all these alternative designs, there's the dumbbell, and then there's a bunch of toruses. There's a torus, and then there's a beaded torus, and there's multiple beaded tori or multiple dumbbells and multiple tori. And the thing I don't like about any of these other designs is there's no variable gravity on these. I mean, you're always at the maximum distance from the central axis, the rotation axis. So And there's not also not as much room inside. I don't know why people prefer these designs. I don't. But I don't know. I guess to each his own. But another idea that O'Neill had was he thought once we started building enough of these O'Neill cylinders, we could have arrays of them. We don't have to build just two together. We could build as many as we want together in a network. And the picture on the bottom shows a big network and a kind of arranged like a necklace. I don't know how many O'Neill cylinders are on this picture, probably about 20 or 30, but they're all rotating about a common axis, and all the mirrors are pointing towards the sun, and there's the Earth in the background again. So pretty cool design. And another thing O'Neill imagined, he didn't think these things had to be stationary. They don't have to stay at the Lagrange points. I mean, if you wanted to have a permanent colony, yeah, you'd have to have them at the Lagrange points, L4, L5. But nobody said you had to stay there. So why not put engines on them? Why not make them venture into space? Like the Enterprise on Star Trek, and even maybe go to another star system eventually. And a big advantage of doing that is it wouldn't be like you're on a space voyage. I mean, you would be on a space voyage, but you'd be living on these colonies. So you'd be simultaneously living on a space colony like people have done before you, but you'd also be venturing somewhere else. So you'd be on a mission, and you wouldn't even have to get to Alpha Centauri during your lifetime. You could wait for your descendants to get there, because it probably took a long time to get there. So anyway, that concludes my talk on space colonies. Thank you for watching. Let's make a better world. Let's hope that this does happen someday, because I think it's a really great idea. And I'll see you guys next time. Bye.